The tire on a car traveling along the road has both linear and angular speed. The relationship between linear and angular speed can be expressed by this equation. Linear speed is equal to s divided by t, distance traveled divided by time. Now, s is equal to r theta because the arc length is equal to the radius multiplied by the central angle. So now if we write it as r times theta over t over time, theta over time represents the angular speed. Therefore, the linear speed is equal to the radius multiplied by omega, which is the angular speed. We said that the linear speed is equal to the radius multiplied by the angular speed, which we write as omega, which look like a W. We need to find the linear speed in the following problem. We know that the wind machine has propeller blades that are 12 feet in length. This is the radius. And for our angular speed, the propeller rotates at 3 revs per second. So we're going to convert our angular speed into radian. 3 revs per second will be converted by multiplying 3 rev per second by 2 pi for 1 rev. 1 revolution equal to 2 pi radians. So revs cancel each other. So the angular speed is 6 pi radians. Let's write a formula for linear speed. V is equal to R multiplied by omega. R is 12 feet, the length of the propeller, and omega is 6 pi radians per second. So V is equal to 72 pi feet per second. A wheel is rotating at 5 rev per minute. We need to find the angular speed. Angular speed is equal to theta in radians divided by time. And theta is equal to 5 revolution multiplied by 2 pi over 1 revolution. So to find theta, to convert theta in radians, we will multiply 50 by 2 pi, which is equal to 100 pi radians. 1 minute is equal to 60 seconds. Therefore, the angular speed, if we want to express it in radians per second, is equal to 100 pi radians divided by 60 seconds, or 10 divided by 6, or 5 divided by 3. So it's 5/3 pi radians per second, which is approximately 5.24 radians per second. A wheel is rotating at 200 rev per minute. We need to find the angular speed in radians per second. Angular speed is equal to theta divided by t. We're going to convert theta into radians. 200 revolution multiplied by 2 pi radians per revolution. Revolution will cancel, and theta is equal to 400 pi radians. 1 minute is 60 seconds. Therefore, the angular speed, omega, will be equal to 400 pi radians divided by 60 seconds. Cancel the zeros. It's 40 divided by 6. So it should be 6 2/3 pi radians, which is approximately pi radians per second, which is approximately 20.94 radians per second. For this problem, we are being given the radius of the chain wheel of the bicycle, which is 3.5 inches. Then we are being given the radius of the rear gear, which is 1.75. Then the radius of the back tire, which is 12 inches. Now, the number of revolutions of the gear wheel, because of we're transmitting power, is equal to the radius of the bicycle, 3.5 inches. So it's the chain wheel divided by the radius of the gear wheel multiplied by the number of revolutions of the chain wheel. So the chain wheel has a radius of 3.5. The gear wheel has a radius of 1.75. And this will be multiplied by 150 rev. So we get 300 revolutions. Now 300 revolution will be converted into radians, and it'll be our angular speed. 300 rev multiplied by 2 pi for 1 rev, and our angular speed will be 600 pi radians. Now the linear speed will be the radius of the back wheel multiplied by the angular speed. The radius of the back wheel is 12 inches or 1 foot, and the angular speed is 600 pi radians. Now the linear speed will be 600 pi multiplied by 1 foot, which is approximately 1885